Good morning, sir.
Good morning, children. Please sit down.
Thank you, sir.
So, my dear students, today we will study about redox reaction, which is made up of two words, Red plus X. This Red stands for reduction and OX stands for oxidation. So we are going to study about reactions which involve oxidation and reduction. Right? I'll show you some demonstration on the basis of which we can know whether it is an oxidation reaction or a reduction reaction. And let us start with burning of an ordinary piece of paper. You see the burning of paper?
Yes, sir.
Can you just tell me what are the things required for anything to burn? Yes, Tuti?
Sir, oxygen and sir, a material which is to be burned.
You mean to say only oxygen is required?
So actually the atmosphere, the
It
practical
is
atmosphere.
air or the atmosphere, you can say, which helps the thing in burning. But in particular, if you come, then it is oxygen, as per your knowledge goes. But we have some other materials also in the presence of which the burning can take place. So one of the ingredients which you know that oxygen is glycerin required for the burning of the paper or anything else. Now, what we see after the burning is left, this is ash. And not the paper. You see the part of the paper and the ash both. So there is a change. What type of change has taken place? Yes.
Sir, color change takes place.
Color change from what to what?
Sir, it changes from white to black.
White to black or gray. Right? Sit down. Now I'll take the ignition ribbon is with me. The ignition is a
Metal.
This was a piece of paper and now we have got the metal magnesium. This is just a solid metal. See the burning? What's the color of the light? White. And now, after the burning, do you find the change?
Yes, sir.
This is original magnesium weapon.
Yes.
What's the color? Gray. And burning part, after the burning, you got the color is
White.
Can you say these two are same materials now?
No, sir.
No. That means some change has taken place. What type of change?
Sir, physical change.
You call it a physical change?
Sir, chemical change.
Chemical change, very good. Because burning has taken place and this white material, can we convert back to the original magnesium rubber?
No, sir.
It's not possible. So, whenever you cannot convert back the original material, then we can say that it is a chemical change. Now, what exactly has taken place in this case? We started with magnesium, which is a metal. Then we have burned this in the presence of oxygen, air. We have burned in the presence of air which contains oxygen, and when burning is taking place, you get a white powdered substance which is magnesium oxide. This is magnesium oxide after burning. Same way, when you have burned the paper, it was carbon plus oxygen. We have seen paper plus oxygen from the air. This forms CO2, carbon dioxide, CO2 plus the ash, which is something other than CO2. Now, in both the processes, what is common? Yes, Anjali?
So oxygen.
Oxygen is common in both, which is reacting with once magnesium metal, second with the carbon of the paper, forming carbon dioxide, and it is magnesium oxide. Now, can anyone balance this equation? Yes, Ram? Yes.
So 2 will be coming on the end. So on the side of 2 and U.
Then?
So on M2.
Very good. So now, next equation. Yes.
That's 2C plus O2 plus 2C.
No.
So it's already balanced.
Here it is already balanced. It is already balanced because there is 1 atom of carbon, 2 atoms of oxygen. Again, we have got 1 atom of carbon and 2 atoms of oxygen. So, what you find in both the cases that oxygen is being added to another element. In one case it is metal, in another case it is carbon, which is a non-metal. So maybe it is metal or non-metal, both the cases oxygen got added up, and this particular process of addition of oxygen, we call this as oxidation. So, we start with the oxidation. Now, can anyone define this process of oxidation? Yes? Yes, ma'am.
So the process in which addition of oxygen to a substance and removal of hydrogen from a substance.
Just be only up to oxygen because we have not introduced anything else. It is only oxygen we are taking up. So you give your definition only
the process
based
in
upon
which addition of oxygen to a substance is called oxidation.
Yes. The process of addition of oxygen to an element is called oxidation, or the process in which addition of oxygen takes place is called oxidation. Now I'll show you another demonstration. I take again the magnesium ribbon only, take in the test tube and then add to this hydrochloric acid. You see the solid metal in the form of flakes in the test tube, and this one is a liquid acid, hydrochloric acid. You find some change?
Yes, sir.
Reaction is taking place vigorously.
Yes, sir.
And if you want to have a feel, you can touch it also and see what you find. But careful.
It's too hot.
It is too hot.
Yes.
So what I have done in this particular case now, I have taken same magnesium plus added hydrochloric acid. What change do you think has taken place in this case? What reaction has taken place? Yes, Kopika? Yes, this is MgCl2 plus H2. Again, can you convert back this MgCl2 and hydrogen back to magnesium easily? It is not possible. So we cannot convert. This also is a chemical change. Now we have to see what change has taken place. Can we just get something about oxidation and reduction from this reaction also? Hydrogen is a part of chlorine. Hydrogen is a part of chlorine, and now hydrogen is separate. Right? Magnesium was alone, and now it is magnesium chloride. So can we just relate this to the oxidation reduction, what has taken place in this case? Yes?
Sir, hydrogen has been removed.
From?
So hydrogen has been removed from HCl and it has been separated, and Cl2 has been added to Mg forming magnesium chloride. And so H2 is now it is a separate atom.
See, magnesium is converted to magnesium chloride. See, we said that oxidation is an addition of oxygen, but now it is not only the oxygen which can oxidize the things, it is chlorine also which has got added to magnesium. Magnesium has been oxidized to magnesium chloride, but this is not a oxygen. So just to give you the idea that oxidation is not only an addition of oxygen, it is addition of some electronegative radicals, which are halogens, and addition of the electronegative radical also will make the process same as oxidation. And then HCl, what has happened in this case? The chlorine has been removed from the HCl. So this addition of electronegative radical to magnesium has oxidized magnesium, but removal of chlorine from the HCl has reduced hydrochloric acid. That means magnesium is oxidized to MgCl2, and what is reduced in this case? HCl is reduced to hydrogen. So we have got now introduction of both oxidation and reduction. One is the oxidation is addition of oxygen, and another is addition of electronegative radical. And in this case, the removal of electronegative radical, we call that as a reduction. Opposite of oxidation will be always reduction. Now, if you see this reaction, hydrogen plus oxygen, when we pass electric spark, this reaction of course cannot be shown by ordinary lab. Now we get the formation of, in this case, hydrogen combining with oxygen will form water. That will form H2O, and if we balance this equation, then 2 here and 2. So what has happened to the oxygen in this case? It is added to hydrogen. So it is oxidation. So hydrogen is oxidized. And what has happened to oxygen in this case? Hydrogen is added to this. Oxygen is added to hydrogen, and hydrogen is added to oxygen. So in this case it is reduced. Addition of oxygen is oxidation, and addition of hydrogen is reduction. Addition of an electronegative radical is oxidation, and removal of an electronegative radical is reduction. So oxygen, this oxidation and reduction, they always go side by side. If you find addition of oxygen is taking place, we can call it oxidation. Addition of hydrogen is taking place, we call it a reduction. And the opposite of these two will also vice versa. The removal of oxygen will be reduction, and the removal of hydrogen will be oxidation. Is that clear? Now, this particular reaction, again, there are some reactions where you won't find the involvement of oxygen or any electronegative radical, I'll take some examples where you will not be able to judge from the oxidation and reduction based on oxygen and hydrogen. So we take copper sulfate and zinc. This is copper sulfate solution. What's the color of this? Blue. Have you seen this particular thing? This is zinc metal solid and shining in gray in color. I'll just put in this. Are you seeing some change taking place?
Yes, sir.
What initial change will you see in this case?
So the color
is changing. It is becoming lighter and lighter, and I'll show you what is happening to the zinc metal. See the color.
Yes,
this is silver. Great. Shiny. And this one is
black.
It's a dark brown, but it's looking like black. It is turning to brownish, and this one is only shiny. That means you find a change. One, the color change in the copper sulfate. Another, you are finding a brown color coming on the zinc. Now, what change is exactly taking place? See, copper sulfate is always blue in color. When copper sulfate is not there, then the color will not be blue. And ultimately, you find that it is becoming almost colorless. It will take some more time, but after about 5 minutes, you see there will be no color at all. That means the solution becomes colorless. And what change do we find in this case is zinc is forming zinc sulfate, and then we are getting the formation of copper sulfate has changed to zinc sulfate, and then copper has been separated out. This dark brown color this one is blue solution, and this one is gray solid, and this one is colorless solution. Now in this particular reaction, this also is an oxidation reduction reaction, but there is neither the involvement of oxygen nor hydrogen. That means oxidation can be redefined on the basis of electrons, which is we take as the latest theory to be used for the definition of oxidation and reduction. Now, this sulfate has got 2 negative charge and copper has got 2 plus. And what is the charge on zinc? No, 0. And here it is 2 plus, and this is 2 minus, and here it is 0. So what we find, the sulfate minus 2 remains as minus 2. There is no change in the sulfate. On the copper, it is 2 plus and changing to copper 0. How the positive charge can change to 0? How can we change the charge positive to 0? Yes?
So when it accepts 2 electrons.
When a negative charge is given to the element. Now in this case, 2 positive is there, we need 2 negative. And that can come in the form of electrons. So copper ions have taken up 2 electrons to form copper in the solid state. Same way, zinc, we start with the 0 and then we get zinc 2 plus. So how this zinc can change to zinc ions? Yes? Rahul?
By the loss of electron.
By the loss of it. Because addition of electron will give a negative charge and removal of electron will take a charge. So when we take out 2, then this is 0 means neutral. The number of electrons and protons are same, equal in number. And when we take out 2 electrons, that means there will be 2 extra positive charges, the protons, and they will give a charge 2 plus to the zinc. So in this process, what we have seen is the gain of electrons, and in this case there is a loss of electrons. Right? Now we have to see how can we define oxidation and reduction. If you just compare this reaction with the magnesium oxide you have taken, I'll just compare with your knowledge, previous knowledge of magnesium oxide. Magnesium plus oxygen forms magnesium oxide. Right? This was 2. Now magnesium was 0 here, and this oxygen also in the elemental state, it is 0. Here it is 2 minus, and this one is 2 plus. We know that magnesium, when burnt in the air, reacts with oxygen, forming magnesium oxide, and magnesium is oxidized to magnesium oxide. Is that clear? So what change is taking place in the magnesium here? Magnesium 0 changes to magnesium 2 plus. So this can be possible when some electrons are lost. That means minus 2 electrons. So where is the loss of electrons? In zinc. See, now we are coming from oxygen to the electrons. Comparing the same example, which you know that magnesium gets oxidized when it is heated in the presence of air or oxygen. Now we have loss of oxygen in the zinc also. So this, that means this process is oxidation. And opposite of oxidation is loss of electrons, and this is gain of electrons. So this will be reduction. So now we have to define what is oxidation in terms of the electrons. Yes?
So the process in which atoms or ion loses electrons is called oxidation.
Anybody else who can define this? Same. Yes?
So the loss of electrons from an element is known as oxidation, and the gaining of electrons in an element is known as reduction.
So the process in which there is a loss of electrons is called oxidation, and the process in which there is a gain of electrons is called reduction. Now in this particular reaction, or any of the reaction, copper in the presence of ions is oxidized or reduced? It is. Copper sulfate is reduced to copper. It is only copper, not the whole of copper sulfate. So copper ions are reduced to copper, and zinc atoms are oxidized to zinc ions. So what you observe in this reaction, the oxidation and reduction is taking place in the same reaction. In the same reaction, both oxidation and reduction are taking place, and the reactions in which oxidation and reduction take place simultaneously are called reaction. Is that topic clear to you now?
Yes, sir.
So the reaction in which oxidation and reduction are taking place simultaneously, they are called redox reaction. Can you tell me any reaction of double decomposition? Any reaction of double decomposition? Say I'll take silver nitrate. This is aqueous plus NaCl aqueous, this forms AgCl white precipitate plus it will be NaNO3. This is aqueous. We have done this reaction in the lab also. The test for chloride ions, that we add silver nitrate solution. If the white precipitate is formed, we call this reaction a positive test for the chloride ion. Now, can you see what is oxidized and reduced in this case? This is an application part now, not direct question. What is oxidized and what is reduced? Any one of you? I'll write the charges. This is +1, this is -1, +1, -1. Yes?
So sodium is oxidized.
Sodium is oxidized to what?
So sodium nitrate.
What is the change in charge?
So the charge comes from positive to negative.
Is that? Is that? Yes?
Sir, in that silver nitrate.
How? Just tell me in the basis of the electrons addition or removal. Silver is plus here.
Yes, sir.
And silver is plus here.
No, sir, but we have added chlorine. So
there is no question of chlorine here or all thing. That definition is gone now. The latest based on the electrons. What is the change in silver? Silver +1 is changing to again silver +1. So what is this? Oxidation reduction. There is no change. Same way sodium also is +1 and is changing to. So what is the change? No change at all. This reaction is the one in which there is neither oxidation nor reduction. It's only a displacement reaction. Or you call it a double decomposition reaction or a double displacement reaction. Is that clear?
Yes,
so there is one category of reaction which does not involve oxidation reduction, and that is a displacement reaction or a double decomposition reaction. But rest all the reactions in the universe or in your body will be all involving oxidation or reduction. Is that clear?
Yes, sir.
Now, I'm just leaving one assignment for you all. Just work out on in your surroundings, the changes taking place in your surroundings, and see where the oxidation and reduction is taking place. So you can write down in your copies. One assignment is, think of some situations or some reactions in your surroundings where the redox reactions are taking place. Think of some situations in your surroundings, maybe in your house, in your school campus, or in the market, wherever you go, and see anywhere the redox reaction is taking place. You will find hundreds of those reactions. So in your next class we'll discuss that and ask you the examples of those. Right? Second, think of some changes taking place in your body. That is the biological reactions where oxidation and reduction are taking place. I'm sure you'll be able to gain some knowledge, maybe in the market or at home and within your body, where the oxidation and reduction is taking place. Because I said, except double decomposition reactions, all reactions are redox reactions. Is that clear?
Yes, sir.
So, thank you, my dear children. Be cheerful and be prepared for the next class. Come prepared with your assignment. Thank you.